Hi, Pre-Calculus, and welcome to your final video from me for this year. And this video is brought to you by water. Cool, clear water. All right, back to business. So, this video is going to go over the midterm review, the free response section from the midterm review. All right? And number one, number two, we're going to go over those two, and I'll choose a few more. All right, number one's a long problem. It says find the roots of this polynomial, x to the fourth minus 2x cubed plus 9x squared minus 24x minus 36 equals 0. All right? Just to remind you, that's a fourth degree polynomial, so it should have 4 roots, right? So you got to keep, cross-check that with your answers. Type in the function in the y equals in your calculator, all right, and then hit second table, or second graph, I should say, and check the table until you find a root. There's one, right? 3 is an x value that makes y 0, so 3 is a root. Not to be confused with negative 16, which is the y-intercept. That has nothing to do with this, right? You're not looking to see where x is 0, you're looking to see where y is 0. So clearly, 3 is a root. To find all 4 roots, we use synthetic division with the number 3. So we found 3 was a root on the calculator, and you can use synthetic division with that. Right? If you don't have a calculator for this, then you've got to guess and check to find your first root, right? So to do that, you would use the possible roots, the possible rational roots would be factors of 36 over factors of 1. So numbers like, 1, 2, 3, 4, 6, 9, 12, 18. Those are all possible roots, right? But your calculator allows you to find a root very quickly instead of guessing and checking with all of those possible roots. All right, so you found a root is 3. Do synthetic division, bring down the 1, multiply, and add, and multiply, and add, and multiply, and add, and multiply, and add. Now, what remains are the coefficients of the third degree polynomial, x to the third plus x squared plus 12x plus 12. So we've chopped down this fourth degree polynomial using one of its roots, and now we have a cubic polynomial to find the roots of that. So far, with our, do I have room over here to write? I'll write the answers over here. Right, so the roots are going to be, one of the roots is 3, and the other 3 roots will come from this one. All right, now on your calculator, you could type this one in and find a root and use synthetic division again, but it's going to be a lot faster to use factor by grouping in this case, right? Grouping is going to work out here because take out an x squared, we're left with x plus 1, and then take out a positive 12, and we're left with x plus 1 again. So because we have the same expression here in the parentheses, grouping is going to work out. Factor out the x plus 1, and we're left with x squared plus 12. So now we know another one of our roots is going to be negative 1, right? So this here is the factorization of that cubic, right? Negative 1 is one of the roots. And for the other two, x squared plus 12, that can't be factored, so we kind of want to set x squared plus 12 equal to 0 and solve that quadratic equation. Subtract 12, and then square root. And the square root of 12 is 2 root 3. So the square root of negative 12 is 2i root 3, or 2 root 3i. So our 4 roots are those 2 real and rational roots, and these 2 imaginary roots. Right? They're the 4 roots. If you forgot plus or minus, it should be kind of obvious because we should have 4 roots, right? Not just 3. Right? So this is one of the longer problems on the midterm. So I wanted to make sure I reviewed that for you guys in this video. All right, number 2. Number 2 is just asking you whether or not those 2 functions are inverses. Right? So the way you determine if 2 functions are inverses is you use composition. Okay, so you want to ask yourself, is f of g of x equal to x? Or you can do g of f of x, right? If this is true, then the functions are inverses. If it's not true, then they're not inverses. So that's what's expected of you, all right? So if we do, let's actually do g of f of x in this case. This is going to be a little bit easier because of the type of functions we're given, all right? So f is 3 plus root x, and g is x squared minus 6x plus 9, right? And you could factor this if you wanted, right? X minus 3 squared. That might be a smart thing to do here, but let's pretend we didn't do that. Now we're trying to figure out what's g of f of x. Show this work. So we now plug in this expression, right, what f equals, in for the x in function g, there and there. So we get 3 plus root x squared minus 6 times 3 plus root x plus 9. Right, I'm just doing composition, plugging in the f of x instead of x in the g function. Now we just simplify this. Remember, we can't distribute an exponent over addition, so we have to write this out twice. And then we can distribute the negative 6, minus 18, minus 6 root x, plus 9. Foiling here, we get 9 plus 3 root x plus another 3 root x. So we get 9 plus 6 root x. Root x times root x is just x. And when you combine like terms here, everything cancels out except for the x, right? That's all that remains. 18, negative 18 is gone with those two 9s. Negative 6 root x, positive 6 root x. We're left with just x. And this shows you that the functions are, in fact, inverses. Okay, so yes, they are inverses. That's the work you would do to check that. Problem 3. This is a very quick problem, but it's involving exponents, and it's been a little while since we studied this. So I want to make sure you guys remember. You did a very nice job with this unit, for the most part. So let's remind you guys what you can and what you can't do using exponents properties. 3x to the negative third, y times z to the 0, and that's all squared. All right? What I'd recommend you do at first is not to change this into a fraction, right? X to the negative first is 1 over x. So, all right, you could write that, but I wouldn't recommend it. I wouldn't recommend changing negative powers into fractions at the beginning. Do that later on in the process. All right, so I'm just going to kind of carry this down. I'm going to raise all this to the second. There's no adding or subtracting, so I can just make sure I distribute and raise every factor to the second power. 3 to the second is 9. X to the negative third to the second. We multiply exponents. We get negative 6. Y to the second, right? And then z to the 0, that's just 1, right? So this just goes away. Just times 1, it's gone. Now, we don't have that much more work to do. Negative 6 times 9 is negative 54. Here we're going to add the exponents. Negative 1 plus negative 6 is negative 7. Y squared. Can't leave negative exponents in the answer. So this is really 1 over x to the 7th. So that's just going to drop down to the bottom of the fraction. Right, we really have negative 54 times 1 over x to the 7th times y squared. So we end up with this answer. All right? Next problem. Problem 5. Okay, is 2x plus 3 a factor of that cubic polynomial? So, if you're asked if an expression is a factor, then I would recommend checking the root, right? So if 2x plus 3 is a factor, only, well, I should say 2x plus 3 is going to be a factor only if x equals negative 3 over 2 is a root. So I would just plug in negative 3 over 2 into that polynomial for x, negative 3 over 2 to the third, either on a calculator or by hand, and check and see if you get 0, right? That's what it means to be a root. It's a value for x that makes the polynomial equal to 0. Copy that down right? I think so. All right, you can try to do this by hand, just because I feel like getting out the calculator. 4 times negative 27 over 8, and this is going to be plus 8 times positive 9/4 plus 27 over 2 plus 18. All right, 4 over 8 is going to reduce to 1/2. We're going to make this go a little quicker. 8 over 4, that's really times 2, so it's plus 18, right? 2 times 9 is 18, plus 27 over 2 plus 18. These two go away. They make 0, but 18 plus 18, you kind of want it to be 0, but they're unfortunately not opposites. You get 36. So that means that negative 3 over 2 is not a root, right? This is not a root, so this is not a factor. 2x plus 3 is not a factor. No. Right? I'm going to second guess myself because I'm like, should one of these be negative? I don't think so. No, it's just sort of tricky how those numbers worked out. All right, problem 8 is the next one on my list here to go over. This is another long one. This is kind of as long as problem 1. This is stuff from back in September, right? So problem 8, find a cubic equation of that form, y equals ax cubed, etc., with the roots 5 and 2 minus I. Now, it's cubic, and I'm just giving you 2 roots, so it might be confusing. But remember, if you're given an imaginary root, then its conjugate is also a root always. So if 2 minus I is a root, 2 plus I is also a root, right? So my recommendation for this problem is going to be a bit of a long problem, all right? But I recommend using sums and products to handle the imaginary roots, all right? So, okay, we know one factor, we're looking for an equation, right? So y equals, we know one factor is x minus 5. The other factors, okay, instead of writing x minus 2 minus I, x minus parentheses 2 plus I, and being very careful with the trinomials there, the sum of these 2 roots, if we just added up 2 minus I and 2 plus I, right? Just doing this basic math, 2 minus I plus 2 plus I, we get 4, right? That tells you the opposite of your b value. So the b value in the quadratic that goes with those 2 roots is going to be negative 4. We got 4 for the sum. The product of 2 minus I and 2 plus I, be careful, we get 4 plus 2I minus 2I, can go away, and then minus I squared, right? Remember, I squared is negative 1. So we get 4 minus negative 1, which is 4 plus 1, which is 5, right? So the sum was 4, so that means we have x squared minus 4x, and the product is the same as the c value, right? So this is going to save you a lot of time using sums and products instead of doing it the long way and writing out x minus the quantity 2 minus I, x minus the quantity 2 plus I. It's very messy work, right? Highly recommend using sums and products. Do show that work, right? The product especially, the sum we got, it was 4, right? The product was 5. So that's why we get this quadratic. And now, because I asked you for the expanded form in the instructions, you guys just do the multiplying x cubed minus 4x squared, and later minus 5x squared is minus 9x squared. And then we have what? 5x plus 20x is plus 25x. And then negative 5 times 5 is minus 25. And that's our answer, all right? Just to remind you, the most efficient way to handle a problem, we're asking for the equation given the roots. If your roots are irrational or imaginary binomials like this, I really recommend using sums and products as a quicker way to get the quadratic part there. All right, number 10, looking for the inverse equations. All right, and then I'm going to go over number 12 and call it a day. All right? Number 10, inverses. Maybe we won't do all 3 of these, but let me see. Well, why not? They don't take too long. 10a, the inverse of, all right, I'm not going to write down the problem itself. F of x equals x plus 6 to the third minus 5. So first thing we do to write the inverse equation is to switch x and y. So instead of y equals, I'm writing x equals y plus 6 to the third minus 5, all right? And then just solve for y, right? Just get y by itself. So that's going to be doing PEMDAS in the reverse order. Add 5, cube root, and then subtract 6, and we're finished. Add 5, then take the cube root. So all of the x plus 5 is going to be under the cube root, right? All of that. Right? And then subtract 6, and we're done. So that's it. All right? If I did that too quickly, hopefully you heard what I was saying out loud. All right? So again, add 5, cube root, and then subtract 6. So that's what we end up with for the inverse. And you should use inverse notation. if the function is 1 to 1. All right, so the original function there, a cubic function, is always 1 to 1. All right, letter B. Logarithmic function is also 1 to 1. So we have x equals log base 2 of y minus 9 plus 1. I'll take this one a little bit more slowly because it's a logarithm and logs are a little harder. But we're going to subtract 1 first. I'll show you every step this time. All right. And now you know the inverse of a log function is an exponential function, right? So at some point, you've got to make sure this is in exponential form. And that's what you do right now. Once the logarithm is by itself, once you've subtracted the 1, put this in exponential form. If this logarithm equals x minus 1, what that must mean is that 2 to the power x minus 1 must equal y minus 9. Now we just add 9, and that's the end. We're finished. All right, so the key step, it's not so intuitive necessarily, is going from here to here, right? Remembering that the inverse of a log function is an exponential function. Once you're here, write this in exponential form. Just add 9 and we're finished. Right? So we had f of x, so it's f inverse of x equals this. That's the answer. All right? And I guess you could check your work on the graph and the calculator too, right? If you graph a function along with its inverse, remember there is reflectional symmetry over the line y equals x. So there's going to be a mirror image over the y equals x line. So if you graphed the original function a with the inverse, you should see that mirror image over the y equals x line. All right, and the last one for number 10 is 10c. So this is an exponential function, switching x and y first. So 4 times 3 to the power 2x minus 5. So the inverse is going to be logarithmic, right? So we'll start by dividing by 4. X over 4 equals 3 to the power 2x minus 5. And at this point, as you might have guessed, we use logarithms. Take the log base 3 of both sides. And we end up getting 2x minus 5 equals log base 3 of x over 4. Right? You really don't need to show this middle step here. You're really just writing this expression in logarithmic form. All right? Log base 3 of x over 4 equals 2x minus 5 is the log form of this. Right? You don't really need to show you're taking the log base 3 of both sides there. All right? And from here, oh, did I forget to write y? I'm sorry. So I switch x and y. I forgot to change the x to a y. So that's a y, that's a y, that's a y. And now add 5 and divide by 2, and we're finished. So log base 3 of this. I'll even put that argument in parentheses to show that that's the only part of the argument. Now we have to add 5, and then we're going to divide the whole thing by 2. So it's a little bit of a messy answer, but that's it. That's the answer here. Okay, so inverse of an exponential function is logarithmic, and those are the steps you'd be expected to show how to go between the two forms. All right, I want to do just one more. Problem 12. All right. So we're asked to solve this equation. I'll write the whole thing out. Bear with me. Log base 4 of x plus log base 4 of x plus 4 minus log base 4 of 2 equals 2. Right, this kind of goes along with the logs video that I also had made. So what I would recommend you do here is condense the left-hand side of this equation using log properties, the addition and subtraction properties. Condense all of this to a single log, to the log of a single argument, I should say. All right, so logs are being added, so you multiply these arguments, x times x plus 4. And then you're dividing, because logs are being subtracted, you're dividing that by 2. So this is the logarithm of a single argument. This is all one expression, all right, and that equals this 2. All right? Now that you have this, we write this in exponential form. 4 to the second must be equal to this, x times x plus 4 over 2. And now we've got a quadratic equation to solve. Right, this is 16. 16 times 2 is 32. 32 equals x squared plus 4x. Just distributing and multiplying by 2 in the same step. Take away 32, x squared plus 4x minus 32 equals 0. Factor x plus 8x minus 4. So x equals negative 8 and positive 4. However, one of these does not make sense, right? The argument has to be a positive number in a logarithm. So negative 8 is not going to work. If you check the work there, this is not going to work. It's called an extraneous solution. So x equals 4 is the only solution to this equation. You can even check your work if you want. All right? So good luck with studying, and I will see you in class for your midterm.